In the previous lesson, we looked at proving whether or not a quadrilateral was a parallelogram. Today, we're going to look at the properties that are true if we are told the figure is a parallelogram. So I'm going to ask you to trace your hand once again, and we're going to label this one about parallelograms. And you will see that many of them are going to be very similar to the proving parallelograms from yesterday. So this is not, it will be a parallelogram if this is true. Today it is, if it's a parallelogram, then this is true. So the one that sticks out on our sore thumb is if it's a parallelogram, then it will have two sets of opposite parallel sides. So if you're told the shape is a parallelogram, then you know the opposite sides are parallel. Then we have our main two that most people remember. If you are told that the figure is a parallelogram, then you know that it has two sets of opposite congruent sides. So if they say, hey, this figure is a parallelogram, then you know the opposite sides are going to be congruent. And if they tell you, hey, this is a parallelogram, then you will know that two sets of opposite angles are congruent. So if they say this is a parallelogram, then you can automatically know that the opposite angles are going to be congruent. Now, I put a ring on this finger today, and I did that for a reason, because rings are round, right? So obviously not that size, because that wouldn't fit around my finger, but rings are round. When you think about a ring, you're thinking about making a circle, right? So when you make that circle, you can go whichever direction you want to around that ring, but you're going to end up coming back to where you started at some point in time. Here's why that's important. This is a totally different finger than the one we did yesterday that talked about one pair being both parallel and congruent. This is different. That's why I put the ring on it, because that's like your left ring finger. That's different from all the other fingers. It's totally something that stands out on its own, and that ring on it, I'm hoping, will remind us of this. So what it's supposed to remind us of is consecutive angles add to 180 degrees. So consecutive, like if you think about somebody getting consecutive hits at bat, they're getting a hit in a row, or somebody has two consecutive aces in volleyball, then they had an ace and immediately got another one the very next time. So when you are thinking about your ring around, what I'm referring to that is, here is my parallelogram. As I go around that parallelogram, each pair that I am touching with that arrow is going to add up to 180. So let's say this angle right here is 80, then this one would be 100. And if this one's 100, then this one's 80. And if this one's 80, this one's 100. And if this one's 100, this one's 80. They have to keep pairing up to equal 180 degrees as you walk your way around the parallelogram. That's why I use the ring finger for that, because you're going around the parallelogram. Each pair is going to add up to 180 degrees. Now your pinky finger is going to be very similar to the prove one, because when you are told that it is a parallelogram, then you know for a fact that the diagonals bisect each other. So these are the properties of the parallelogram. The ones we wrote down yesterday were what we call the converses of those. Converse just means backwards. So like I can say, if it's raining, then it's cloudy. and its converse would be if it's cloudy, then it's raining. You just switch the if-then statement around. So 4 of these 5 properties have a converse. It's the ring finger that doesn't have a converse. So not everything that has consecutive angles will automatically, supplementary, will automatically be a parallelogram, but it is true of all parallelograms. That's why it can't have a converse, but it is one of the properties. So keep this handy so that you'll be able to use it as you go through not only your assignment, but also the quiz later on. Okay, so ABCD is a parallelogram. So the first thing I wanted to make sure we talked about was the order of these letters. When you have the name of any polygon, it doesn't matter what it is, you can start at whatever vertex you want to start at. But then you go clockwise and name them in order after that. So I'm going to put A up here, and that means clockwise would go this direction. So the next vertex I reach should be B. Continue clockwise, this one needs to be C, and then continue clockwise, and this one needs to be D. So I just wanted to cover that because I do think it's important, and it's something we tend not to talk about or cover because we think people just know it, but you should always name all of your polygons in order around the figure. Okay, so it tells us it is a parallelogram. What does that mean? Well, it means that the opposite sides are going to be parallel, so I can mark that. Don't forget the other pair of sides also then are parallel. Mark that there. And then it means, okay, so that was our thumb, and then it means opposite sides are going to be congruent. So this side will be congruent with this side, and this side will be congruent with this side. And it means, number 2, opposite angles are congruent. So angle A, that whole angle, would be congruent with its opposite, which is angle C. And then angle B, the whole angle, would be congruent with angle D, the whole angle. Okay, so that was definition. Opposite sides are congruent, opposite angles are congruent, and then we get our ring finger. So we know that around this shape, the angles are going to add up to 180 degrees. So I know that these two are going to add to 180 degrees. The same thing's going to be true all the way around the shape. So you can continue writing those in there if you want, but I'm just going to draw the arrows. But every pair, so A and B are going to add to 180, B and C are going to add to 180, C and D are going to add to 180. So that was our ring finger, and then our last one is our diagonals. So the diagonals have to bisect each other. So this diagonal has to get cut in half, and this diagonal, I needed 4 there, that diagonal also gets cut in half. Now you'll notice I used different tick marks for all of those because I don't have anything knowing that like the diagonals are the same as any of the sides, so I had to put something on the diagonals that I hadn't already used. Okay, how are we going to use the properties that we talked about today? So if you are told that something is a parallelogram, then you know those properties to be true. So if EFGH is a parallelogram, find the value of the variables. So we see variables occurring 3 times here. We have X, Y, and Z. So first of all, let's start with X. So X is up here in corner F, it's opposite corner H, and H is marked with 102. And opposite angles are congruent. So that means X will also measure 102 degrees. Y is over here at angle E. Now it's right next to angle H. So they are not congruent because they're not opposite. Rather, they are consecutive. So these 2 angles in a row, like that, they need to add to 180. So I know that, make sure I'm writing where you can see, 102 plus y needs to equal 180. So we are going to just subtract 102 from 180. which I know is what some of you were doing naturally, but just keep in mind sometimes it's easier to write an equation because you don't just have numbers there. So let's see, that would be 80 minus 2, so 78. So y is 78 degrees. And then our last variable is z. It's down here on this side, on side HG. And because this is a parallelogram, opposite sides will be congruent. So HG will have the exact same measure as EF, which is 15. So that means HG will have a measure of 15. And I don't have units on there to use, so I would just put 15. Let's try a couple more questions like that. And we are told PAUL is a parallelogram. Find the value of each variable. Okay, so over here at angle L, I have a 75 degrees. Up here at a U, I'm being told that A, which was over here, AUL, so that whole angle is 3x plus 21. Here I have point S. There's an A here, a 10 inches here, a Y up there, a Y down here, and nothing over here on side PA. So, let's see, alphabetically, the first one of those would be A, so let's just do that one first. So A is on a diagonal. Since it is a parallelogram, then I know the diagonals bisect each other, so I know that this and this will have to be congruent to one another. So therefore, I know that A is 10 inches. Because I was told it is a parallelogram, then let's look for X. So I was told that this is a parallelogram, so therefore I know that these two angles right next to each other, not opposite, but right next to each other, are going to need to add to 180. So I know that 3x plus 21, which was the angle up here, plus 75 will need to add to 180. So I can, some people just like to go ahead and subtract that 75, and they say, hey, I know this angle up here needs to be 105 degrees, and then solve it that way. That's fine, whatever way you want to do it, doesn't matter to me. If you want to collect the 21 and the 75 first, that works, you still get the same answer. All right, so then we get 84, I believe, and then we're going to divide by 3, and we get x equals, let's see, 2 would give me 60, and then another 24 divided by 8 divided by 3 would be 8, so 28. So x equals 28. And I actually don't need the